I just wanted to kind of go over what I'm expecting to see when I get the data file so that you guys and I are on the same page. I went ahead and put up the checklist this morning, so you have a detailed checklist of everything I'm expecting to see, and the rubrics on the second page telling you basically follow the checklist, and then I'm looking at the rubric, say, wow, certain items are missing, half points, or this thing's completely incomplete, no credit on the data or on the procedure. The procedure part of the rubric is talking about making the control lines, the mean and the standard deviation lines, and then also making the chart correctly. So that would be the procedure part of this rubric. And then the professionally written would be the things about the spreadsheet. All the columns are labeled, the date format's correct, and so on. So there's really 3 criteria of performance. That's the data, are the calculations right? The procedure, are the columns correctly put in there? And is the chart correctly prepared? And then the professional part is that everything's labeled in the right colors and so on. So let's go through the expectations. It's not that hard, but I wanted to be explicit so that you understand what's expected. So the requirements are, at this point of the semester, the training period's over, you should have 15 data points. If you have 14, that's fine. Just tomorrow, after your next data point, that will end the training period. Whenever you have 15 data points, that's all we're going to use for our training period. It doesn't matter if it ends on a Tuesday. Okay. So now it's time to calculate the mean and standard deviation. Pretty simple. The formulas are in Excel, averages for the mean, and we're going to use the population standard deviation. So it's stdev.p. So you'll see that in the spreadsheet. And then we'll set up the watch and action limits, and then we'll create the chart. And so I'm just showing you some of the details. This is what your spreadsheet should look like in general. And hopefully it's not too small for you to see. But up in the top, I'm looking for a header section that has the class, your name, email, and the data source. So if you're doing Bitcoin, tell me, daily difference in Bitcoin. Okay. And then you should have a couple of cells, one for the average and one for the standard deviation. And that's the formula, stdev.p. So since we have 15 data points, we're going to use the population standard deviation. And then you have a column with day. So that's just counting the number of days that you've collected. And then date, the date of those days. If you're collecting just weekdays, that's fine. You'll just have a gap in the date. When it goes from Friday to Monday, not a problem. Okay. And then you'll have the data that you collected. And then if you're doing a daily difference, then you'll have an extra column. That next column will be the difference column. So you just label it accordingly. And then, now that we've finished our training periods, we'll have the average and standard deviation calculated up at the top here. And so this is column D, and this is 4 and 5. And so D4 is the mean. And so this column is just one long anchored cell. Equals, D4, you click that cell and hit F4 and you've anchored it, and then you just copy that down, and that column won't change the whole semester. Because the training period has told us what the mean is for this data, and we're just going to use that same mean the whole semester. So it's just going to be a whole column of a single number. I mean, there might be easier, prettier ways to do this, but this works. Okay. And then we have the mean plus 1 standard deviation, the mean minus the standard deviation. Those are your watch limits. So you see those formulas here. The mean, which is D4, plus the standard deviation, which is D5, and the mean minus the standard deviation. So those are your 2 watch limits, plus S and minus S, and then your action limits, plus 2S and minus 2S. So that's it. Those are your formulas. So you can do this today. I mean, this isn't a problem. You entered 5 formulas in your spreadsheet. And then this is the new formula for you that might be tricky, and we'll zoom in on it in a second. And that is, I'd like for you to set up an if-then statement, okay, so that you don't have to dig through your data and say, were any of these data points higher than my action limit? Let Excel do that. And so this is just zooming in. I wanted to emphasize that average and the standard deviation stop at the end of the training period. They don't continue on for all of the data. Right? So we've trained our average for 15 days, and then we're going to see if it stays the same. That's the control part. We're going to see if that mean drifts, or if the the noise jumps up above our action and watch limits. So we're training our analysis on 15 days of data and then seeing if it stays in control the rest of the semester. So we don't have a running average. We don't have a running standard deviation. At the 15th day, that stops, and then we see if it stays in control the whole time. Let me pause to clarify anything that's any questions you have or concerns. Okay. So, and so then here's this if-then statement. We can use just, logically, if it goes above or below, well, there's an or function in Excel. And so you can set up both criterion. If open parenthesis, and this is the criterion, or either of these cases. So either D8 is greater than H8, and H8 is the high action limit, comma, D8 is less than I8, which is the low limit. So if either this or that is true, then do this. Say, in quotes, beyond action level, comma, if that's not true, then do this. And I just have two quotes with nothing in between them. So it's not going to show anything if you don't have this condition satisfied. So the way the if-then statement works is that if you open parenthesis, you have a criterion test. If that criterion is true, do what's next. If it's false, skip that and do the next thing. Okay? So if, then, else is really the way it's set up. If this, then do that. If it's not, do that. And then you close the parentheses. So this is pretty simple. It's a nice way to put it all in one line. It can test above and below in one if-then statement using that or function. And so that's Boolean logic. You're using the or function to determine if it's above or below, and then using that as a group to tell if it should say it's beyond the limit or not. Okay. So that's the if-then statement, and I'm asking for that. I'm putting that in as a requirement this year. Now here's the control chart that you will create. So you will select if you're doing daily difference, the daily difference column and the date column, and you will do a line chart, not an XY scatter. All through PCHEM1, we used XY scatter because we had continuously variable data in the X and the Y axes. But this isn't continuously variable data on the X axis, it's dates. Okay, so we don't want it using dates as a magnitude, a data point. We want it to be a category. And so a line chart uses the x-axis as categories. So you have date categories, and it also bumps them together, meaning it goes straight from Friday to Monday and doesn't care that there's two missing dates in between. Monday's just the next category. And so it's just plotting by date. There shouldn't be any gaps. And I like to rotate the dates 90 degrees so that you can read them. And so you have to figure some of this stuff out. That's the critical thinking part of this assignment. Is I'm not going to tell you everything that you need to know to produce this chart. This is your goal. Figure out how to rotate those categories. It's real simple. You double click the x-axis and start poking through all the options. Okay. And you'll find it. I think it's nice to plot the training set and the data set with different colors so that you can see where the training set ended and the data begins, like the control part of the data. And so that may not be necessarily something you have the ability to do today because you only have the training set data. But moving forward into the future, then you can change the color. Maybe you have to plot two series. So you have one series that's the training set, and then you have a different series that's that continuing on, and it's a different color scheme. I also don't want smooth lines. If you draw a line on a chart, you need to know the equation for that line. And although this is zigzaggy, it's really just to draw your eye from data point to data point. But I've got a straight line between any 2 points, and I can tell you what that line formula is. A line through any 2 data points, you can figure out what M and B are. But the smooth data line is doing some kind of spline function, and it just creates a very confusing looking chart. Now in terms of the action and watch limits, notice I want the action limits to be red. They're farthest away from the mean. I want the watch limits to be orange, and then I want the mean to be green. Okay. So these are very specific directions I want you to follow. And then the dates are shown in 90 degrees. So this is sort of a map. This is a sort of a full credit control chart. This would be something that you wanted to reproduce. There's one thing that I don't like, that this date and the date labeled crashes into one of the categories. And so I would tell, if this was my entry, I would tell myself, okay, need to move that down. Or move all the dates up a little bit. It needs to look as professional as I can make it. Okay. You need to label the y-axis with your data source, like I have daily change in flow rate. Any questions about this? That's really the assignment. Just turn in your spreadsheet that has a control chart in it like this, properly formatted, and then all of your data columns and everything. Oops, I need to kill it. So your data table should look like this with the action limit. Now, I have mine shown, the if-then statement, I put a little apostrophe in front of that so it would show the formula. You may not have anything in that column after you type that formula in. You won't see anything because you won't have any out-of-control points, most likely. But I'll go in there because I have the spreadsheet and I'll click and check your formula. Okay, so when I'm grading, I will check to make sure that formula is properly done. But you will paste it in there and you're like, well, nothing happened. Well, yeah, something did happen. If you want to test that, you can put something between those last two parentheses and say, okay, so you can see that it's okay. Oh, it's beyond the limit. That's okay. You don't have to be so exact to do it exactly my way. If you wanted to put inside those parentheses that we're okay, just so you have a positive message to say we're within those limits, that's fine. And then your control chart should look like this. And I will check the limits on your average and standard deviation, and then I'll check this Boolean formula, and I'll look at the control chart. So that's everything for tonight. And the checklist is online. Let's see.
That PowerPoint is this one?
I will put it up there, yeah, so that you can see examples.
Yes.
Yeah. And so here's the checklist. It looks really big, but it's just all the little details. So, the header, the data table with all of the different things, date columns, watch limits, and then the control chart with the colors and rotated axes and everything. Also, the charts, when we start pasting these into Word and so on, you've got the data, and it has a box around it. That's fine. But Excel, by default, puts a box around the whole chart. And I don't like that bounding box. It's not necessary, and it kind of breaks the flow in a Word document when you paste that in. So that's another thing that is a pet peeve of mine. Delete that bounding box so that when you paste it into your control chart report, you don't have this box. This sets apart your figure. Your figure doesn't need to be boxed in. It's already, the data is boxed in. You don't need two boxes. So that's on here. No bounding box on the chart. Okay. I think that's pretty clear, and then the rubric's pretty generic. But if you have lots of revisions needed, then you lose some points. But if they're just minor revisions, maybe one or two little typos, you'll get full credit. Yes?
Do we have to describe it? I can put a paragraph.
No, there's no writing on this one. Yeah, this is just your spreadsheet. So just the header, information up in the top left, so I know whose chart it is or whose data table it is, and then so there's really no writing associated with this one. I wanted to just make sure we stopped at this point, and I checked all of your data, made sure everything was being collected correctly, and that you made a good first effort at producing the control chart. So then my feedback on this one will be things like your lines, you're something wrong with your lines or something wrong with your labels. You need to change those, but next time it'll be pasted into a report. And so I'll still be looking for those changes. And this really is it's a long exercise, but it's really a pretty easy exercise. You may be frustrated that you haven't gotten full credit early on, but you're eventually going to have where you have full credit the rest of the semester, because you're just tweaking it and making it better each time. Okay, so that's really all I had planned for this morning. The rest is up to you in terms of asking questions about things on the practice test. So